Hello guys, welcome back to my YouTube channel. Today we'll be talking about optical activity in stereochemistry. So when you hear stereochemistry, what comes to your mind first? We know that it's the 3D arrangement of atoms in molecules and how it affects their properties, like their spatial arrangement, their chirality, whether it's optically active, and then remember the R and S. But don't you wonder, what does the chirality have to do with light? And what does the R and S we see on the paper have to do with light? We're going to answer all this in this video. So now, what does polarimetry mean? This is how we measure the optical activity using a device called a polarimeter. From the word polar, light, and meter means measuring. Now recall from your physics that light is a perfect example of wave duality. So we can see that light is acting as a wave and a particle at the same time. So when it's acting as a wave, you can see that it's going up and down. However, we want to measure the optical activity and we need our plane polarized light to be going in one direction. How do we make this happen? Usually, a light bulb has light waves coming out in every direction. So we place a filter in front of that light and create a slit in between that filter, making it hit. So when the bulb hits the light in every direction, the light that is going up and down, the wave going up and down, is going to pass through that filter, and finally we are able to isolate the light traveling in the one direction. Now, the R and S comes to turn in the light in specific directions. It is going to turn the light, if it's going to be the R, it's going to turn the light specifically to the R, and the S is going to be in the S version. If a chiral molecule rotates to the right, this is going to be called the dextrorotatory. I'm sure you've heard of that word before. And therefore, that's positive. We know dextrorotatory is from a Latin word, dexter, that means right. But if the chiral molecule makes the light to turn to the left, it's going to be counterclockwise. That's negative, and we call that levorotatory. Take note, guys. The R and S does not equal to the positive and negative. They are all different ranking system. The R and S describes the configuration of the chirality center. For example, what did you notice? Okay, let me give you the keywords in naming compounds with R and S. So the first thing you do is identify the chiral center, which is very obvious here. Then you prioritize the group according to the atomic numbers. We can see that bromine has the highest atomic number in this compound, then followed by chlorine, then fluorine. Then the second step is you orientate the group so that the lowest priority, which is our hydrogen, is projected away. That means the H is facing towards the back, which is what is here in this compound. Then lastly, determine if the sequence 1, 2, 3 is clockwise R or counterclockwise S. So we can see it's going in clockwise direction from our bromine. You ignore that hydrogen there, since it's already projecting away, and we are determining if it's clockwise or anti-clockwise, so it doesn't confuse us. So now, guys, how do we name this? This is going to be R-bromochlorofluoromethane. Then our second compound, we can see, is going counterclockwise, just like our doorknob when we're trying to open it. So how will we name this? It's going to be S-bromochlorofluoromethane, because it's going counterclockwise, opposite direction of our R. Now you can pause the video and quickly try to name this compound. See whether it's R or S. Alright guys, that's all for today. Don't forget to like and subscribe if you like this video.